In this video, we're going to solve the festival cruise pricing problem. I have demand parameters for my problem, November and December. So the November demand, remember, is 220 minus 0.18 times the price. So if price is $500, that's 220 minus 900, or we would expect to sell 130 rooms at that price in November. Our total number of rooms is 200, and that's the information that we need for this problem. Looks like a couple places I had merged some previous versions of this problem. This is all November and December, so you can just copy over where it said January and February. And I gave you a partially completed spreadsheet, but let's go back through and make sure we understand where everything comes from. Clear out what we had here. All right, so we're going to use our function that was for our November and December demand functions. We want to know how many rooms could we sell in November and December at each of these price points. Well, for November, we're going to make that equal to B5, and we'll keep everything in column B here. So 220 minus 0.18. So let's go, and also we'll use that relative reference there, times whatever our price is. So we're going to use whatever value is in row 9. So we'll lock our reference on row 9 here. And let's see if we get this 130 number. There we go. So we would expect to sell 130. We're just going to put this as a number. And we should be able to drag it for all of November and all of December. Okay, this looks good, except let's make sure this makes sense. This is going to be 300 minus 0.15 times 500. Okay, that looks good. Everything's good here except we're going negative with our November prices. So let's go back to cell A10 and make that equal to maximum of 0, comma, what we had before. Put a right parenthesis there to end it. Let's drag that over and make sure that goes to 0. Okay, that looks good. We set up our decision variables here. We just make everything 0. Okay, so we set up our decision variables. And we are going to have a constraint. We can only set one price for each month. So we're going to add up the number of prices that are activated for each month, and that's has to be less than or equal to 1. We can't charge 500 and 1500 in November. So we're just going to say, I'll clear these out. Cell M15 is at the sum of this whole row. Well, we're just going to do the sum, and the price is going to add up, or the number that it's turned on is less than or equal to 1. All right, we'll go back through and turn on 500 for November and 1500 for December. This gets us to our other constraint. How many rooms do we have available? Well, we only have 200 available. How many are we expecting to sell? We can only sell 200. So let's write this as some product. The number of rooms sold is going to be 1. This binary variable means it's a 1 if that's turned on, and 0 otherwise. So we can just make some product of our B15 to L16 table, our decision variable table, times our demand table, B10 to L11. And this is 1 times 130 plus 1 times 75. That gives us 205. Okay, so that's a problem. So we're going to need to figure out what the right solution is here. How much revenue are we gaining from each tickets sold at $500 in November. Well, that is going to be our decision variable for $500 in November times the demand. So it's B15 times B10 times B23, and we're going to lock that on row 23 so we can drag that down to December as well. How much money are we making? Let's drag this across. Looks like I didn't. Oh yeah. So how much money am I making? Looks like the only ones that are active are the 65,000 and 112,000, 500, and we're just going to add those up. And I get a total revenue of $178,000 here. Okay, if I would change that around, let's say make this 0, sell 600 in November and 1,400 in December. Okay, I'm still over, but I'm making more money here. So let's formulate this as an optimization problem. And I'll note that you could do it either way, where this could just be the revenue, assuming it's 1, and then you do a some product here. So we could change that around. So cell B24, I would take out the decision variable B15. And so this is always going to be the revenue that I would make from turning on this price in this month. Make some of these columns can be a little wider so we can see the values. Could drag this down, and then my total revenue is going to be some product instead of just the sum. It's going to be some product of my decision variables times my revenue. Okay, and so it would be the same thing. You'd get the same result. Either way of doing the model is okay. All right, so now let's use Solver to figure out what the best possible solution is. And data, Solver, and let's reset this model. Click OK. My objective is going to be to maximize my revenue. I'm going to change. I want to maximize cell B27 by changing my decision variables, my 22 decision variables. So I'll select these. I have the constraints that I can only choose one price for each month. Okay, so I'm going to select cells M15 to M16, less than or equal to cells O15 to O16. And I'm going to add a constraint that my rooms sold, C20, is less than or equal to 200. Click OK. So C20 is less than or equal to A20. All right, so simplex LP. Let's solve and see if we get a reasonable solution. And look what happens here. Okay, I'm setting a price of 800 in November, but in December here, I have two different prices chosen for, maybe 27% of the time I'm charging 1100 and 73% of the time I'm choosing 1200. Let's say that violates our policy, so I have to go back in and add a constraint that my decision variables are binary. Okay, so B15 to M16. Oops, actually that's going to, looks like it went a little too far. It's going to be B15 to L16 is binary. Click OK. And now let's solve it and see what it chooses. All right, it goes with the 1200 rather than the 1100. Stays with that 800 for November, and it recommends charging 800 in November, 1200 in December, to make a total revenue of $204,800, coming in at 196 out of my 200 rooms sold.